All right, now that we've looked at different types of polar graphs and how to create them, we want to do the next thing that kind of comes natural to us in calculus. We want to take a look at instantaneous rates of change along any of these polar graphs. In other words, the slope of the tangent line. So, to find the slope of a tangent line to a polar graph, I want to consider the differentiable function that r, the radius, is f of theta, some function of theta. And I'm going to use the parametric equations, because the parametric equations gives us x equals r cosine theta. So in this case, that's going to be f of theta times cosine theta. And y is r sine theta, and that's going to be f of theta times sine theta. And that gives us that the derivative dy dx is going to be dy d theta over dx d theta. So let's figure out what dy d theta and dx d theta is. If y is equal to f of theta sine theta, then dy d theta will be equal to f prime of theta sine theta plus f of theta cosine of theta. So this is going to be f prime of theta sine theta plus f of theta cosine of theta divided by, well, if x is f of theta cosine theta, then dx d theta will be f prime of theta cosine theta minus f of theta sine theta. The negative came up because I knew I was taking the derivative of cosine. The derivative of cosine is a negative sign, so I brought the negative up front. So this is going to be f prime of theta cosine theta minus f of theta sine theta. So this will give me the derivative dy dx at any point along that parametric or the polar curve. Now, solutions for dy d theta equals 0, provided dx d theta is non-zero, will give me a horizontal tangent. It's just like if I had f of x equals g of x over h of x. Let's make that f prime of x. So the derivative of f is some function of g over some function of h, right? I'm talking rectangular coordinates now. If g of x is 0 and h of x is non-zero, I have a horizontal tangent, correct? If g of x is non-zero and h of x is 0, then the tangent is undefined, which means I have a vertical tangent. So it's the same idea here. So if dy d theta is 0, the numerator is 0. With dx d theta, the denominator non-zero, I get a horizontal tangent. And if dy d theta, the numerator is non-zero, but dx d theta is 0, I have an undefined tangent, which means I have a vertical tangent. So let's take a look at a couple of examples here. Let's find the function for the slope of the tangent line to r equals 2 times 1 minus sine theta, then determine the slope at theta equals 0. Well, what I need is dy dx, which is going to be dy d theta over dx d theta. Well, let's do a little work over here on the side here for a second. Y is going to be equal to r, which is 2 times 1 minus sine theta times sine theta, which is equal to 2 times sine theta minus sine squared of theta. Remember, this is r times sine theta. That's the radius. So dy d theta will be 2 times cosine theta minus 2 sine theta cosine theta. Don't forget the chain rule. Now x is going to be equal to r, which is 2 times 1 minus sine theta times cosine theta, which is equal to 2 times cosine theta minus sine theta cosine theta. Sorry, I kind of got off the edge there, but you can see what that is. Okay. So that means that dx d theta equals 2 times negative sine theta minus cosine squared theta plus sine squared theta. So dy dx is going to be equal to 2 times cosine theta minus 2 sine theta cosine theta divided by 2 times negative sine theta minus cosine squared theta plus sine squared theta. Obviously the 2's cancel out. So really all I have is cosine theta minus 2 sine theta cosine theta divided by a negative, I'm going to do sine squared theta minus cosine squared theta minus sine theta. Sorry, it just felt more natural to write it that way. Now I need to evaluate this at theta equals 0. And when I do, because it asks for the slope and theta is 0, when I do, I'll get 1 minus 0 divided by a negative 1, which is a negative 1. So my slope when theta is 0 is in fact negative 1. So let's take a look at Maple real quick and see if that makes sense, see if it's plausible. So I'm going to do polar plot, and my function was 2 times 1, I forgot the function already, was it 1 minus sine theta, 1 minus sine of theta, and I'm going to let theta go from 0 to 2 pi. And let's do thickness equals 4. I want this thick enough that I can see it, at least on here. And let's make this a little bit bigger. All right, let's see what we got now. When theta equals 0, what's the radius? Well, sine of 0 is 0. So this is 2 times 1 minus 2 times 0, so it's 2. So when theta equals 0, here's my angle 0. I'm at a radius of 2, so I'm right here. That's the point that I'm at, right there. So what's the slope? Well, plausibly, I mean, you take a look at the tangent line, it's going to look like this. That seems reasonable to say that probably is a slope of negative 1. I mean, just look at the graph, that does in fact seem reasonable. Okay, let's take a look at another example. I want to find the function of theta for the slope of the rose curve, r equals cosine 3 theta. Well, again, what I'm asking for is dy dx, which is dy d theta over dx d theta. So again, I'm going to do a little work off here to the side. Y equals r, which is cosine 3 theta times sine theta. That would then imply then that dy d theta equals, well, I'm going to have derivative of cosine, which is negative sine theta. So it's going to be negative 3 sine theta, whoops, not sine theta, negative 3 times sine 3 theta, chain rule, times sine theta, plus cosine 3 theta times cosine theta. Okay, so x is going to be r, which is cosine 3 theta times cosine theta. That would then tell us that dx d theta must be equal to, let's see, again, I have a negative 3 sine 3 theta times cosine theta minus cosine 3 theta sine theta. So let's put this all together here. And what I end up with is this is going to be equal to negative 3 sine of 3 theta sine theta plus cosine 3 theta cosine theta, that's my numerator, divided by negative 3 sine 3 theta cosine theta minus cosine 3 theta sine theta. Now I'm going to erase a little bit of this so I have room to finish this up. Make my eraser a little bit bigger. There we go. That's good. Okay, now what I'm going to do here, even though this is all it asks for is the function of theta, there it is. Let's go ahead and evaluate this at theta equals 0. When I do that, I'm going to end up with, this is going to be 0. This is going to be 1 times 1, so I have 1 over. Everything with sine is going to be 0, so I have 1 over 0, which is a vertical tangent. So I have a vertical tangent when theta equals 0. Well, let's look at this. This Rolle's curve, when theta equals 0, r equals 1. So I know when I take a look at my graph, when theta is 0, I'm in this direction, the point I'm looking at is right there at 1. So let's jump back to Maple and see if that's plausible or not. So let's go ahead and delete this previous one. And this is cosine of 3 theta and I'm going to leave it, well, you know what, I know I'm not going to need all that, so I'm going to go right there. So there's my Rolle's curve. Can make this a little bit bigger. Oops, that should work. Okay, what do I have? When theta equals 0, I'm here. The radius is 1, which is right there. So I'm talking about this point right here. And looking at the graph, it seems very, very plausible, extremely plausible, that the tangent line is in fact vertical, which is exactly what our calculation showed.